We'll talk about AKS in production. One of the issues when you're going into production is which Ingress resource should I use? What are the scaling issues that may appear? What are the problems that may appear? Those moments when your production is down, it's serving a lot of people, you have like 1,000,000 requests coming every day, and you have that moment of, oh boy, it's 3 o'clock in the morning, the cluster is down, the whole cluster is down, not the cluster, the application. What do we do? And after we fix the problem, how do we debug it? Let's figure out what happened and how we can prevent that issue from happening from now on. Make sense? I'll be taking questions whenever you want. So if you have a question, raise your hand. I'll gladly answer. If we run out of time, it's not a problem. I'll be in the community corner, so we can discuss as long as you want. I'll be here until 9 o'clock, 10 in the bar or at the community corner with the other speakers. Okay, so when you're running in a production, most of the cloud providers say it's a simple operation of just click, click, it's going to work. Everything is perfect, rainbows, bunnies, and things like that. No, it's not. When you're deploying a cluster, if you're doing for the dev and test, it works. Going to the portal, click, click, it works. That's good, awesome. But when you're going to production, you need to take things very seriously. Like, do we have, how many nodes do we need? Well, how much resources are being eaten by the application? We don't know, but let's find out. But you can overscale your cluster from the beginning. So you can start with like a 4-node cluster and you only need 2 because it can handle that load in 2 nodes. It's highly available from the start because there are 2 nodes, but you're going to pay extra money for something you don't use. So capacity planning is a very important thing to do when you're working with Kubernetes and microservices, containers in general. Also, if you don't do that, other bad things can happen. So if you don't set resource constraints on pods, and resource constraints are based on metrics. So that pod, which can have 1 container or multiple containers, depending on the scenario, will consume node resources. That's the main idea. It's going to use CPU cycles, RAM, or other metrics that you can export and set alerts or set other rules on them. But if you don't set from the start resource constraints, what will that pod do? If you ever install the SQL Server on a VM and you don't change the default memory settings, you have 1 terabyte of RAM, it's going to eat 1 terabyte of RAM. Do you use it? Nobody cares. It's going to use it from start to bottom. So if you don't set resource constraints, that's going to be a bad thing. And bad things you don't want to happen because they are hard to fix. And when the pod dies, most of the data that was inside it that can help you debug it dies with it. Unless you're sending that log data outside into a Grafana, a Prometheus time series database with monitoring with Grafana, or the Azure Log Analytics service where it can pull all the data from it. Anyway, we'll see what type of bad things can happen later in this session. Continuing on. When you're monitoring, never monitor only the cluster or inside the cluster. One of our clients did something like this. They had like an application that was only monitored from the inside. So everything looked peachy from the inside, but the application was down. They didn't monitor it externally. Okay, you can say it's a rookie mistake. It is, but it can happen. Things that like this can happen all the time. So you need to monitor it externally, and externally for multiple places. Because if you monitor it for, let's say, Europe, maybe US is down. Maybe a path is down. You don't know. You need to know about that. So you can fix it as fast as possible. So if you have a doubt about monitoring or something, monitor everything. Monitor and alert everything. Start from the top and go to the bottom. Why? Because most of the data that you receive, most of the time you don't know which is an error or not. So it's better to start with all of them than trim them down. I know it's not the best practice. The best practice is let's alert only what's useful. Let's find the criteria that's useful. But in these cases, you don't know. You can have a crash of the application, you never got an alert, and maybe Kubernetes in the back end say, okay, the pod crashed, I'm going to restart it. That's the usual behavior of Kubernetes. It will restart a pod if it dies. Well, if you go into the Kubernetes cluster, you don't have any alerts or some alerts, you can see that that X deployment at that X pod restarted 2,000 times, 200,000 times. It doesn't do anything else. It just has a counter that goes up and up and up and up. And yeah, what happens then? You know how we found out about that one? It crashed once a developer pressed F5 on the web page. It crashed then, and he knew that it should be snappy, and it wasn't. So there's a problem. The application should be snappy. Why isn't it? And we found out that they were crashing like hell, but the application was working. So cool stuff for Kubernetes. Now, when you're running in production, you have to have continuous integration, continuous development, deployment, not development, deployment delivery. If you don't, then you have an issue when you're updating your application. So you have V1 of your application, okay, we want to do V2. How do you do it? Well, I'll send the ticket to the IT admins. They'll run that command that says update with the image type. Usually it's the tag latest, which latest is the great one of them all. If it's the latest version, it should be working, correct? And if it breaks, you don't have any rollback possibilities. In this case, the recommendation here is to have a CI/CD tool in place. It doesn't matter which CI/CD tool it has to be. The Azure DevOps one has native integration with AKS, but you can use Jenkins, you can use TeamSeed, you can use whatever you want to use it as a CI/CD engine. As long as the agents that do all the work have the proper tools installed to manage and create deployments in that Kubernetes cluster, you're okay. And also makes your life easier. Everything is as code. You want to do a deployment, you have deployment templates. So you start with YAML. Some people like it, some people don't. I don't. I'm a JSON guy. Even as an operations person, I can read JSON better than YAML, which is, some people say it's something wrong with you. JSON is ugly. YAML is nice. Yeah, that space didn't have to go there. That space is too much. That space is too less. In JSON, accolades, parentheses, I'm done. I know if I screw up, I'll have a squiggly line that says you screwed up. In YAML, it comes with a squiggly line, you screwed up, but it doesn't tell you where. It's somewhere there, like in the Visual Studio compiler. You're missing a comma at line 18, but there are all of them. You're missing it, I know that one. It's gave an error. Yeah. So one other recommendation is to use Helm. Some people like Helm, some people dislike Helm, like a lot. And if you go on Google and you search Helm pros and cons, you'll find a lot of people saying a lot of things. Most of it is regarding authentication. Other things are regarding deployments and rollback and upgrades. It depends. We're in a bleeding edge environment. So when you're using Kubernetes, which if you look at the deployment template and you're seeing beta, you're seeing alpha in the manifests, you're not in LTS stage for that one. So if it breaks, it breaks. You have to be prepared for that one. And Helm is a package manager that helps you deploy containers. And you can have a personal repository. You can use a normal repository where you have templates, where you can deploy containers or microservices end-to-end without a problem. And you can also draft them up, make Helm charts, set them up in your repository, and have CI/CD build them with magic variables that put in the versions and things like that. Plus, you have the rollback capability. You just roll it back. Okay, the deployment failed. Roll back. Not a problem. So that's one of the recommendations. They're working right now on Helm v3. There are issues with v2 regarding Tiller, which is the release part of the system. It manages deployments and releases. Helm is the client tool. Tiller is the one that uses the rest. And they're making v3 without Tiller. So 50% of the people that are, excuse the language, bitching about Tiller, v3 will come without it. So that's one of the things. So, and I don't have to say this, but I usually say this. When you're using latest in the containers, you're shooting yourself in the foot from the start. Never do that. It can go from your pods, or you may have clusters that you created for, let's say, machine learning operations, because keynotes today were mostly on machine learning, unless you saw the Stacy, which was dancing on the stage. You can have drivers. Let's say I'm spinning up a cluster with GPUs. Those GPUs require a driver for NVIDIA. If you use the latest tag as it's recommended in all the documentations, the public documentations, you might have a problem, which happened last week. Last week, the cluster died. Not the cluster died, everything died. We did an RCA, what's happening, and we noticed that, there's something wrong with the driver. What's wrong with the driver? NVIDIA updated. NVIDIA did an update, the driver crashed, Kubernetes pulled, oh, it's latest, pull a new version because there's a new version available. I'm going to use the new version, then it's crashing everything. Okay. Then they had the problem with TensorFlow. TensorFlow comes in multiple versions depending on multiple video card types. And they were using latest dash GPU. Now, if you have the latest and greatest GPU, everything is perfect. But if you don't, you have, like, say, the last generation, that pod will not start. And it will give you like a very, very interesting error that, I'm sorry, but you don't have CUDA. You don't have CUDA. Okay, so I'm paying 7,000 or 8,000 euros per month to not have CUDA. Something is wrong there. Anyway, going on. The next topic when we're covering this subject is which Ingress resource should we use? And there are multiple Ingresses. These are the most common. You can say, okay, I know another one. I know another, I know another. I agree. They pop up like every day, something new, something interesting. But these are the most common. So Nginx is the first one, and Ingress is the entry point to your application. Each and every one of those Ingress controls has pros and cons, so you need to choose carefully depending on which situation you have. And you're not blocked at using only one, so I have to choose very carefully which Ingress controller I use because I'll use it for my whole deployment. No, you can install them all if you want. It's not a problem. We actually did that in production. They don't screw anything up, nothing happens. So you can use whatever you want for whatever multi-tenant scenario you want to use. Nginx, it's, like I said, it's the most common controller. It's easy to install, easy to deploy, easy to manage. Well, boring to manage, to be honest, the Ingress controller, but it has some, it lacks some things, like dynamic service discovery. Think of this. I'm deploying my pods. I want to put them under my Ingress. I want to connect my pods between my Ingress. How do I do that? Well, you have to annotate everything in that Ingress deployment chart. If you don't, it won't work. Easy as that. Another one is that it doesn't have a status and monitoring page. So I have to rely on metrics. If it gets metrics, if it gives metrics, because it's a hit and go with this one, you may not know that you have a problem with the Ingress controller and may be debugging the wrong situation, the wrong application. So you're getting an HTTP 500 page, your application may be down, may be a problem. But Nginx is not giving you any status. Then what you're doing? You're going to the application, you're going to check the application and see what's happening. And you're going to waste a lot of time. Anyway, it's the most common, it's stable and reliable. So I've rarely seen it crash, and when it crashes, the magic of Kubernetes restarts it, everything is up and running. And the best practice is never deploy one pod with an Ingress controller, because if you have high availability above the cluster, you need to have high availability on your pods as well. So minimum of 2 Ingress controllers should be deployed, a minimum of 2. This is mostly because of resource constraints, so you need to manage your resources properly. So you start with 2, you do load test, you see how much it can handle, then you continue on. Another thing is that the default configuration is bollocks, to be honest. So if you ever installed an Nginx in a Linux box, you're going to see that it has like a very, very lax configuration, a very lax one. And in the container space, that doesn't work, because if you're spinning up worker processes, and those worker processes do not know the jails part, the C groups. So it doesn't know that it has any pod constraints behind them, has no idea. So where does it go? To the node, and it's going to constrain the node for resources. So you're going to have connections, it's going to spawn workers, and those workers will eat a lot of resources, whereas you don't want to do that, even if you have constraints on the pod. So that happens. Anyway, that can be changed. By default, Nginx can handle like 10,000 connections on the default configuration if the backend application, the application it's serving, is properly working. If you do some configurations, it can go up. But the one that purely Ingress controller, a load balancer, like a real load balancer, where you really want to do like excellent load balancing, then HA proxy is the one which should be used. By default, without any tweaking, without any hassle, it can handle 100,000 connections and can saturate 40 gigabyte network cards. If you give it a higher type of gigabyte card, like 50, 100, it can saturate that as well. So it's pretty nice. HA proxy is open source and paid, so you have paid support for it. Nginx as well. The idea here is that they make their money from other types of business. They sell products with HA proxy on them. The cons is that it's a pure load balancer. So Nginx, it's a web server and a reverse proxy. HA proxy, it's a pure load balancer with very nice load balancing algorithms. So that's something awesome to take into consideration. And you can also do combinations. You can do HA proxy and Nginx, then your pods. You can do those types of combinations. It's a little bit risky because you're adding stuff in the architecture, and might break and you don't know where, so you have more debugging time. So if you don't have logging, like I said, log everything. If you don't have like those huge logs to sift through and then see what happens, you might go into problems with that one. People do it, they work nicely. That's one of the caveats. And this is traffic. I was looking for the AE. Traffic, most people call it traffic, but the AE is the Latin one. So traffic is a newcomer, a very, very newcomer, but has a lot of juicy features when it comes to microservices, pure applications, whatever you want. And those features are being developed, more are coming, more bugs are being squashed, and it looks quite a good replacement for Nginx, for example. It also has a dashboard for monitoring. That dashboard for monitoring has also service discovery, so you can see everything in that dashboard. It is publicly available, which can be locked down. That might be the first caveat, so you should know about that one because you can access it from the outside. That will pose a security issue. And has Let's Encrypt out-of-the-box integration. You should just tell it, here's the application, HTTPS please. And with Let's Encrypt, you don't have any reason to say, I don't want HTTPS. HTTPS comes with some issues, so the encryption and decryption of the packets has CPU cycle overhead. So if you had like 100,000 connections being served and you have put on HTTPS and that went down to 30, that's a load balancer problem which can be fixed. Offloading. Some people recommend doing offloading outside the cluster so you don't eat the resource of the cluster, but it depends a lot on the architecture. Also, the cons for this is it doesn't support TCP, so it's only HTTP. So if you don't have TCP, it's kind of an issue, but right now, the pseudo-stable version doesn't have TCP. There's an alpha which has TCP, but I never recommend alpha in production, unless you like it awesome. One other issue for it, and it will come, the hitless reloads. So hitless reloads, which Nginx and HA proxy actually know how to handle, means that if a worker has an issue, it's going to drain those connections and then restart the worker. This one, dead. So if you have like sessions, it kills them. Anyway, and Azure specific one. This one is something that I never recommend in production, and you'll see, and you'll understand why. Basically, it's backed by Nginx, but it's custom made. Has external DNS automatically set up, so when you put in application routing, it creates a DNS zone, it creates everything in the back end, and when you publish your application, you just say, okay, I want a DNS entry, I want that, and it will automatically do everything for you. You can configure this manually as well, and that's the recommended path. So if you want to have automatic DNS records every time you update a service or you add a new service, you want automatic certificates, you can do that manually. If you want to do dev and test or use the Azure Dev Spaces feature where you pull a specific container in your personal work environment, you're working basically in production, but not exactly, you're getting something else. You're working on it, you're debugging it, you fixed it, you push the code, it goes automatically in production. But you're doing live testing in production, but not. That's the main idea of the spaces. But it's a complicated feature to be configured, and like I said, never recommend this in production. Never use it in production. If you use it in production, you actually enjoy having a rough time in your life. Brandon Burns said, don't use that in production. So if the PM that works on your Kubernetes says that, it's a thing they should ignore. But dev and test work perfectly. Less management hassle. Anyway, another one, like I said, it's hard to manage. And the next part is, if you have issues to it, it's hard to debug. If you have to debug, it's not worth it. I'd rather kill the cluster and create it back again than doing that, than doing debugging on it. So. I forgot what the time was. Anyway, so scaling issues. Like I said, autoscaling depends a lot on metrics. If you don't have any metrics, you cannot have autoscaling, plain and simple. If you want efficient scaling and you have to use the horizontal pod autoscaler to actually do scaling, it's a simple thing. You have to have resource constraints. No resource constraints, then I don't have to do autoscaling, pure and simple. Cluster autoscaler is another system that scales the cluster. So you have nodes and you have deployments and pods. The nodes are the VMs that your pods sit on, and it's based on HPA. Now, if HPA schedules pods and says, okay, I do not have any resources, and you can see that clearly in the logs, it says it cannot schedule, it's pending, it's blocked, it's something like that, then cluster autoscaler will see that event and say, aha, okay, I need to add a new node, we are at capacity, and it's going to do that automatically. It takes time, so don't think autoscaling is a click next action, it's done in 30 seconds and it works. It's time, so based on that, metrics should be a little bit lax when you're autoscaling. So you don't want to autoscale your pods at 95% CPU. It's a bit too late. Go lower with that one. And cluster autoscaler works only on virtual machine scale sets. So this feature, which is in preview right now, it's not recommended at all in production. We actually tried to use that in a pre-staging environment. It didn't kind of work. It crashed a lot, but that's what you get with alpha versions, preview versions. You don't get any SLA, so you're playing around. But the nice thing is that cluster autoscaler just says, hey, VM scale set, add a new instance. And scale set will do that fast and very idempotent. So give me more, give me less. Plus it can have multiple node pools. Node pools means I have a pool where I put my front end. I have another pool that's based on other technology, let's say Windows. We need to use .NET framework in containers, and you have to have a Windows node pool. You can have them both under the same umbrella. So you have Linux, you have Windows. That's with the VM scale set preview that is right now. So if you want to play with it, it's easy to play around. Caveat, it's going to crash a lot. If it doesn't crash, you're not doing something properly. You have to, if you're actually doing something properly, you're going to crash it. So take like a production grade application, put it on it, and you'll see how many issues arise. Okay. One thing that happens very, very nicely is that HPA, if it's paired with cluster autoscaler, might not scale down the pods. So you might say, okay, we did autoscaling, we set up our metrics, how do you test that? Well, you do a load test. That's pretty simple. But some people, and that happened like 2 months ago, some people did the load test. Everything was nice and dandy. It scaled up nicely. They put the metrics correctly. By the time it came to the 95% threshold, up closely to have hangs, never happened. A new node was spun up. It worked perfectly. Yeah, there was an issue. They forgot to scale it down. So imagine the 10-node cluster, pretty expensive cluster, scaled up to 100 nodes. Test done. Everything is perfect. Let's go to a beer. Then next month later, the CFO got a very nice bill. And yeah, that happens. Why is that happening? Now, cluster autoscaler will not evict nodes and critical systems if the pods can't be moved because like a node selector or affinity. So if you have node selector and you're missing nodes, there are cases of that. Node selector says that that pod should go on those type of nodes. So let's say I label my nodes and say I have a multiple pool cluster. I have a pool with GPUs, I have a pool with very fast CPUs, I have a pool with a lot of memory, and so on and so forth. If the node selector has, okay, go to GPUs, and you don't have that many GPUs, it's going to get stuck there, and you're going to pay a lot, because it cannot evict those systems. If it cannot evict, it's going to keep it like that. And if your pods are mapping local storage, I've seen that happen. So the concept, it works on my machine, and containers solve that problem of it works on my machine. Well, it doesn't solve the problem of attaching local storage. And it works on your machine, sure, but when you're going into production and you're attaching local storage and volatile clusters, well, you're going to have some problems. That happened as well. And in production. Affinity rules, same thing. So I want my pods to stay not together or together depending on the situation or the business case of the application. If you don't have affinity set right, because of that affinity, it's not going to scale down the cluster. Plain and simple. Okay. The next part, next interesting part is when you're having a problem. So people say, our systems look fine. Everything is perfect. Now, if you're seeing events like these, pending, evicted, terminating, and so on, crash back, loop back, whatever, you're having a problem, a very nasty problem. And on eviction, it's pretty lax. The Kubernetes is pretty lax on it. Basically, it doesn't evict them, and I've seen the system pods being evicted because the resource constraints were not set properly. So the production pods, the application, was eating into the critical system, the Kubernetes critical system pods. They got, okay, evicted. They were using much more memory than the cluster had, and they set priority. My application has higher priority than the critical systems. And they said, okay, Kubernetes, well, if you set it that way, I'm going to do it that way. I'm a robot. I'm not a human being with a mind. Anyway, if you see this, it's bad. But you can have things like, our systems are working. But if you have a lot of evicted pods, it's not a good thing. It's a scaling issue. This is when I was creating a new cluster, like, when was that? 1 hour ago happened. So this happened to me, but I've seen it happen a lot of times, usually, in production. Updates, node not ready, things like that. So you're doing an upgrade. I'm moving to the next upgrade, next version for Kubernetes. You set up an upgrade, then you're going to get like something like this. It's failed, nodes are not ready, but when you're going onto the node, you're saying, I'm ready, hi, go ahead. Everything is working properly. What happens here? Well, how do you fix this one? Support ticket. You don't actually do anything else, because if you upgrade to the latest version, you cannot upgrade again. If you reboot the nodes, it's not going to change the status in the portal page. But if you go to Microsoft, you say, I have this, it's working, but it's in a failed state, fix it for me, they'll fix it. Yeah. It's something in the backend. So you have like a timeout at the proxying stage, as it looks. The Azure portal has a proxy inside the resource there. If it times out, it might get false data and everything is working, but you can get like a signal. You can have alerts in resource creation, and you can get alert, cluster is down, it's in a failed state, and you're going to panic. Usually that happens at 3 in the morning, usually. I know from experience. Okay, the next thing where our systems look fine is the application is dead. Now, what's happening there? Everything shows that the pods are up, so you're running the command, okay, are the pods in a terminal state? Is there something wrong with them? What's happening? Or are there any critical system down? What's happening there? Well, you're going to see logging shows pods up, metrics show some traffic, that's the usual response. I'm not a developer, I don't know how much traffic I should get, but I'm seeing something moving there in the graphs. It's pinging like a heartbeat. If it's pinging, it's okay. Awesome. The systems are fine, and why should I do a root cause analysis in an application problem? Everything looks fine, logging shows fine, throw it to the developers, not my problem, usually. And something like this looks. So you have everything in this state, no restarts or some restarts, and it looks like this, but everything is down. How do you fix that one? Well, you start by killing services. Usually you need to figure out how you do that, how to do the debugging phase. So you have a multi-application, multi-pod application. You have multiple services in those pods, in that deployment. First thing to verify, okay, we don't get any traffic from the external side. So if we go to the web page, it's going to give us errors. Okay, let's figure out why. First, you need to debug the application. Where is it giving error? On the front end, on the middleware, on the back end, what's happening there? If it's on the front end, easy peasy, kill the pod, bring it back again. If it doesn't fixes the problem, kill the ingress. If it doesn't fixes that problem, okay, I'm not gonna say it, but you know. Another one, if the back end or the middleware is not responding, you need to verify if pod-to-pod communication works. Basically, if I go into a cluster and I see these IPs, which are marked as cluster IPs, these are not IPs mapped in Azure, these are internal IPs. So the cluster communicates with the pods using these cluster IPs. It has native service discovery. So if I want to deploy something and say, this is my front end, this is my back end, I'm going to name it like that, he's going to know that. You're not going to need a lot of networking to do. In high-scale operations, you'll need to know some networking, but that's a different topic, a very complicated topic. So you have to verify not pod-to-pod communication. How do you do that? Okay, the front end is working. You go into the front end pod and you ping the other pod. You ping it. Okay, it's dead. Reboot it. It's still dead. Okay. That's a problem with a critical system. So usually it's kubedns or kubeproxy. If these if this one or this one, either then they show running, they might be in a failed state. Something clicked there and it's a failed state. So you have to kill them. And something like this happens. And That's the error you get. So I like Google. They give awesome errors, great in debugging. This is something that happened once. I have had a problem with Google when we set up SSO. It gave us, nah, it's not working. Well, why is it not working? Nah, it's a server error. Which server? So it's a Google error. No, actually it was a configuration error, but how do you do that? Well, you have to inject yourself in the HTTPS with Fiddler, get the response, decode the response, and see what's the error or what's sending that you're getting this error. Fun times doing those types of debuggings, yeah. Anyway, these are the ideas that can happen. These are the ideas. These are the situations that can happen. It's going to happen to all of you if you're going to use Kubernetes anywhere. Doesn't matter if it's Azure, Google, or Amazon. Doesn't matter. So you have that, whoa, we have an issue. Nobody pushed code. No pods been updated. Nothing happened. It worked for 1 week, then it started crashing. What's the solution? These are, first you restart kubeproxy, DNS, or restart something. Restart everything if it happens, like that one. It's 3 in the morning, I want to sleep, I have to get up at 8. You'll get the slides, you will have the slides. You don't have to take pictures, but if you want, you can take them. These are useful commands when you do like a critical analysis of the system and making it back again so you can sleep. But usually if you delete, and delete is not an operation that actually deletes them. It deletes the pod, and Kubernetes will say, okay, I have to reschedule the pod, not a problem. You do that, it's going to restart up the pods. But if you do that and they do not fix the problem, then you can say, nope, it's dead. There's a huge issue. And the part that's broken at every cloud provider is that you have to manage the data nodes. So with EKS, AKS, and GKE, you're getting the management layer managed by the cloud operator, but the data layer where you're putting your pods is managed by you. So if you don't manage it well, you'll have to reboot the nodes. And well, it's not the best practice, you actually have to figure it out, but you're in that, I restarted everything in the system. It's not working, it's not okay, what's the sysadmin way to do it? Well, reboot it and let's see from there. Usually turning it off and on again should work usually. And the brute, you have two options with that one. You have the brutal way where you go into the portal and say, reboot them. It's not that gracefully, but in that type of situation when everything is down, this is the fastest one ever. Or you have a nicer way where it's a PowerShell, I'm a PowerShell guy, a shell script which gracefully reboots the nodes. It drains them, it moves the pods over, it reboots them. When it's back up again, it's going to schedule pods again and do that in a nice manner. And I'll show you how. Yes, please. So the question was if a data node, are you talking about data node or the other ones? The VM node. So if the VM node is, the question was, will the cloud provider intervene if there's an issue with my cluster? The answer is no. Automatically, so automatically no, you have to intervene. The master nodes, which are managed by the cloud operator, that's in their garden, they manage it. If they fail, they have to fix it. But the data nodes are in your garden, you have to manage them. It's not a full SaaS-like service where you just put your pods in. You have to do some operations on the data nodes as well. Patch management as well. Only the data nodes. You don't have access to the master nodes. You cannot see them, you cannot manage them, you cannot do anything to them. That's Microsoft's thing. And if you figure out after a reboot that it's not working, then it's a Microsoft problem. That happened as well. Microsoft or cloud provider problem, so it doesn't matter. It's a problem behind it. Usually, upgrades solve the issues. So being a bleeding edge system, The problem there is that you have to go to GitHub on the Kubernetes side and look for issues. Issues that might look like that. So the thing that happened here, and this was in production, here is an example, I'm not showing the production cluster. That cluster had 56 nodes. Select all, reboot. That's what's happened. Nothing worked. And we thought, okay, let's reboot it gracefully. Okay, time is ticking, money is losing. We don't get money, we have a problem. Okay, reboot it. How long it will take, you're not going to see it. It's a VM reboot, so usually VM reboots in Azure are fast, but it's going to poll it. It's going to poll, it's going to verify, and that's the main idea of the demo. So, I'm going to do this one-handed. Let's see if it works. If not, I have my trustee here. So, reconnect. This is the script, the main script for rebooting. It's not perfect. You're going to get some, it's not perfect. But the idea here is, okay, it's going to, can you see the screen perfectly? No. I forgot something. Okay. Mark Rusinovich, bless you. Better now? Okay. So, it expects some inputs. These can be given at the script level. You don't have to go to the script and type them. If this is just an example here. It expects the resource group where the cluster is, the main cluster. It expects the cluster name and the region. After it sees that, then it's going to put up a group, which is the data node group. And it has a function which waits for the status. So it reboots the node, waits for the status. If the node is back up, it's going to go to the next node, and so on and so forth. So you can see the whole function here, and it's going to say it's going to drain the node, and draining means gracefully shut everything down and move all the traffic from that node to other nodes, and then reboot it. Because if you're doing it brutally, like I said, you're going to have some discussions internally. Anyway, so let's go here. So I'm doing this right-handedly. One hand. Okay, let's see. The magic of scripts. It's going to give up some errors, but if I sit here and just look at it, it's going to, well, my cluster is dead, probably. But it's going to be like something like this. It's going to be draining the node, it's going to look at the node, and it's going to wait. This is an error. So it actually works. It's polling to see if the VM gets back up. After it finishes, it's going to allow the node to be scheduled again, and after it's being scheduled, it's going to reboot the next one. So this is the graceful way. But if you are in those moments where you cannot afford waiting, then yeah. And in the portal version, let me go to the portal. How do you get there? Basically, when you're deploying Kubernetes in Azure, and I'll zoom in immediately. Once you create, you're going to get two resource groups. Let me filter that one. Okay. So this is the management, the pseudo management layer of the Kubernetes cluster, and here are the data nodes. So if I want to see what's happening on those virtual machines, I can go here and I'm going to see, okay, I have a 3-node cluster. I can see it's an availability set, so for high availability. It has some OS disks, it has some NICs, NSGs, a load balancer, a public IP. If I want to reboot a VM, I can go to it like this and just say restart, stop, delete. I can do that. It's not recommended, but you can do that. And actually can even go to this part here, which is called serial console, but it's not going to allow you to get in. There's a procedure for that one, a pretty lengthy one. And it's going to give you something like this. Even if you allow boot diagnostics, it's not going to work because you have to use SSH keys. If you don't, it's not going to work. So that's how you do it. If you want to see that dashboard that I had there, I went here to the virtual machines part. select all, restart. And this is how we did it in production. Yes, it solved the problem. We have an RCA, and it was a Kubernetes issue. It wasn't a user error, as Microsoft said first. It was a Kubernetes issue. But first thing it was that it's your problem because you don't have resource constraints set up, which was the case. Resource constraints weren't set up, but the cluster wasn't loaded. It was like 85%, it was okay. Anyway, we figured that out. This is the next part, the post-mortem. So not going to go into actual post-mortem, but how do you actually get to do the post-mortem? So usually you have to explain that one. So I have 10 more minutes left. So how to perform RCAs, now the serious part. This is the most serious part. When you're having an issue like this one, this was a very critical issue. If you have to restart that many nodes, somebody's going to ask for answers. What do you do in that case? Well, you need to roll up your sleeves and start SSHing into each node. That's a painful operation, a very painful operation, because it cannot be done easily. You have to have a pod spinned up in the cluster for SSH, then push in a key, a SSH key, and then SSH into each node. After you SSH into each node, like so, you have to look for the following logs. So you get everything from this part, everything you get from there. Then you run this command here, which targets the cluster, the Kubernetes cluster. And you just input here the date it happened. Usually it's better to cut some from the time. So if it happened at 10:30, go lower, 8, 7. It may be happened before. It may be something that triggered it. So it was happening, but then the cluster said, okay, I'm done, and dropped the mic and went to the beer. So that might happen. And you can find out what's wrong with it. So this is a way to gather all the Kubernetes logs. Then the nasty part starts. You have to sift through them. So sifting through logs is not a pleasurable thing to do. And what I recommend is, first of all, transferring the logs to somewhere where you can download them. It's not easy. You're SSHing your inception SSH and SSH and get the logs. Okay, how do I get the logs actually? Do I put them somewhere? What do I do? And the solution is a website, a very nice website called transfer.sh, where it gives you a CURL command to put that file securely somewhere. You get the download link, and after you get the download link, you can bring it back on your log analysis machine. So that's an easy way to do it. This is not for Kubernetes only, for any Linux machine. It's awesome to use it when you're in a highly restricted environment. The next one is a system center tool. It's called CMTrace. The log format is pretty readable for this tool. So if you have, like we had 60 gigabytes of log data, yeah, we had to do that. And they were doing it line by line. I said, guys, we have a tool for that. It's a free CMTrace tool. Let's look in that one. So popped up CMTrace. It looked at the log. Then we filtered it for warnings and errors. And voila, 60 gigabytes down to only errors and warnings. The reality there was a trigger. So it was multiple failures happening in cascade. So when it failed, that we need to brutally restart it, multiple things happened until to that point, yes. So first thing was the deployment of the client's deployment started starving out the resources of the cluster. The cluster didn't manage that well, and it's an open issue right now. After the cluster said, okay, I'm going to handle this, and it handled it gracefully up to a point. After that, it started killing off services inside the container. So usually your container is one service, one container, and if you kill the service, the container dies. In this case, something hanged in the Docker system. So it Kubernetes is on Docker. Docker was constrained and it got killed. It got killed, it restarted, it got killed, it got restarted. After that happened, what happened there? The system, the client application was failing. It was eating in critical systems. kubesvc, the service redirector, started having issues. Then kubeproxy started having issue. Pod-to-pod communication was affected. Then kubedns, service discovery, and everything else started having issues, but it was handling it. Until a point where Docker said, nope, I'm not going to do anything, and the Docker on the data nodes died and hanged. So you had like a situation where everything is running, you can do new deployments, nothing will work because networking inside the VM was dead. You didn't have anything. So this is like 2 weeks worth of RCA dumbed down in a couple of minutes, but that's what happened. This tool is a godsend. It's free to download, System Center 2012 download, System Center tools for that. CMTrace, it's installed, works on any log file. If it's nicely parsed, it looks for types of errors like ease, warnings, things like that. Debug stuff, information looks like this. Warnings like red in your face. Warnings, yellow. And that's how, and you filter it. And it helps a lot to do your debugging. Now, some best practices. I usually say something, but I don't usually do it. So, like Yoda would say, and I'm not going to repeat it, most issues usually can be solved with proper resource management. So in the end, that RCA proved that there were some resource management issues, but it still shouldn't have happened because critical systems should have priority. It was a standard deployment, only resource constraints were not set up correctly. Patch management is still required. So if you log in to a data node, it's going to say system reboot waiting. When are system reboots happening on your data nodes? Never, only when you're doing an upgrade. So there's a tool which gets set up as a daemon set. Daemon set being it installs on all the nodes in the cluster. It's called Cured, and it's going to do patch management for your cluster. So if you have a 10-node cluster, it's going to gracefully drain the node, do upgrades, reboot it, and then schedule it back again. What happens here is that when there are updates available, there will be a file, so every 24 hours, there will be a file called reboot me or something like that. It's a file created. This tool looks for that file. Once that file is open, it's going to reboot that node. Pretty simple. If you don't do that and you think that, okay, I don't have to do any patch management, I don't have to do any security like most cloud providers say, you might fall in some issues that only reboots can solve them, or an upgrade of a version. They may say, go to this version of Kubernetes when the problem was a package on the data node that caused the problem. So you're on a quite stable version of Kubernetes, you're going to a lesser stable version to fix a problem that can be resolved by patches, patch management. Okay, monitoring the cluster and apps, always a must. So things like application insights injected in your containers, it's a must, so you can get all that application data. If you're not a Microsoftie, you can use Prometheus and Grafana for time series data logging. Log analytics, say again? Yeah. Log analytics for enhanced monitoring, and if the cluster needs drivers, always use the version tag, always. Some useful resources, so you'll get this in the slides. And thank you for your time and questions. So I have 3 minutes left.